All right. So still dealing with simplifying rational expressions. I guess this could be your part 2. This part, though, the emphasis on this part is on opposites. So let's talk about opposites.
What chapter is this?
Okay, opposites. Okay, so what is the opposite of 8?
-8.
-8. All right, so remember opposites in terms of the number line are on opposite ends of 0. So 8 and -8 are the same number of units away from 0. So the opposite of 8 is -8. And in fact, when you add them up, when you add two numbers or two terms that are opposites of each other, what sum do you get? 0. What is the opposite of -3x? Positive 3x, right? Positive 3x. Now, the easy part about these is that they're monomials. We're about to do one where it's not a monomial. But one thing I need to remind you about is that if you divide opposites, so you see like 8 and -8 are opposites. If I divide them, what is their quotient? Remember, quotient is division. What's their quotient? What's 8 divided by -8?
-1.
-1. What is -3x divided by 3x?
-1.
-1. So whenever you divide factors that are opposites, they reduce to what number? What? Not 1, -1. They reduce to -1. Okay, now, so when I looked at 8, all I did was I changed the sign to find the opposite, right? So 8 became what?
-8.
-8. -3x became
Negative.
3x.
Positive.
So what is the opposite of, and let's say the first one is 5 minus 3x. What's the opposite of 5 minus 3x? -5 plus 3x. So you just take each term and you change the sign. You could have also written it as, instead of saying -5 plus 3x, you could have said 3x minus 5. They mean the same thing. These two mean the same thing. Okay? What is the opposite of 6 plus 2x? What's the opposite of 6 plus 2x? -6 minus 2x. Or if you want to, you can put the variable first, so you would say -2x minus 6. Now, just like I did a while ago, when I looked at the opposite of 8, which is -8, and I divided them, I ended up with -1, right? -3x divided by 3x is -1. Let's look at these in that perspective as well. So if I look at 5 minus 3x and divide it by its opposite, which is -5 plus 3x, what should that equal? What should that equal? 0? Who said 0? -1. They're opposites, right? They're opposites. So when you divide factors that are opposites, you better get what number? What factor? -1. So 5 minus 3x divided by -5 plus 3x, which is the opposite, should be -1. Just like over here, what's 6 plus 2x divided by -6 minus 2x? What should that equal? -1. Now, I'm going to go back to this one here. I'm going to rewrite this. I'm going to say 5 minus 3x divided by negative 5 plus 3x. And what I'm going to do is that numerator, just to show you that you do get negative 1, that numerator, I'm going to factor out a negative 1 from the numerator. If I factor out a negative 1, what does that numerator in parentheses become? Negative 1 times what's a positive 5? Negative 1 times what's a positive 5? Negative 5. Negative 1 times what's a negative 3x? Positive 3x. And my denominator, I'm leaving alone. What do you notice about these two factors right here? They're the same, so I can reduce these. When I cross them out, we talked about the last class period, don't just cross them out. What factor is left in its place? 1. And so look at what we have now. We have negative 1 times 1, which is what? Negative 1. My denominator is 1. And what's negative 1 divided by 1?
Negative 1.
Negative 1, which is what we said it was supposed to be. So when you divide factors that are opposites of each other, you end up with what quotient? What factor? Negative 1. Okay? That's going to be important. All right, now let's look at this one. Let's go ahead and simplify. Each of the following. Okay, number 1, we have 2x squared minus 21x plus 27 divided by 4x squared minus 9. All right, now remember we talked about last class period. How do you simplify this rational expression? What's the first step?
Look for GCF.
Okay, the first step is to do what though? The first step is to factor, right? That's your first step in simplifying a rational expression. First step is to factor. All right, now let's factor the numerator. To factor the numerator and the denominator for that matter, you look for a GCF. The GCF is 1 in both cases. So how do I deal with the numerator then? That was in your last test. How do you factor that numerator? The two binomials. All right, so you get 2x, x, and you got to be fluent. We've already spent quite a few weeks on factoring. That should not be an issue anymore. So when I said, how do you factor this, y'all really should have been more proficient with what you told me. You should have been quicker. So it'll be 2x and x, 27, 9 and 3. Let's try 9 and 3. And what's going to work, and remember the last sign's positive, so these signs have to be the same. And they're both negative. Now before you go on to the next part, check this. What's the outer?
18.
Negative 18x. What's the inner?
Negative 3.
Negative 3x. When I add them up, do I get negative 21? Yes. And then a negative 3 times a negative 9 is a positive 27. How do you factor the denominator? Difference of two squares. So 2x minus 3 times 2x plus 3. All right, so the first step was to factor. What's the next step to simplify a rational expression? Reduce. What's the first factor you see in the numerator?
2x negative 3.
2x minus 3. Will that reduce with anything in the denominator? Yes. When I cross them out, though, what do I put in its place? 1. What's the next factor you see in the numerator? Will that reduce with anything in the denominator? No. All right, so let's talk about how to write the answer. What's 1 times x minus 9? X minus 9. What's 1 times 2x plus 3? So there's your answer. That's how you want to write the answer. Okay, number 2. 3 minus x divided by x squared minus x minus 6. So I want to simplify this rational expression. What's the first step? Factor. All right, the numerator, the GCF is 1, so I can't really do anything with the numerator. How do I, and the denominator, the GCF is 1, but I can factor the denominator because that's a quadratic trinomial. And so how are you going to factor the denominator? The two binomials. And what's going to work, let's see, x and x, 3 and 2. And the 3 has to be negative, the 2 has to be positive. And so you can check, the outer is a positive 2x, the inner is a negative 3x. When I add them up, I get a negative x. And a negative 3 times a positive 2 is a negative 6. All right, so I've factored. Once you factor, what's the next step? Reduce. What's the first factor you see in the numerator? In fact, what's the only factor you see in the numerator? 3 minus x. Do you see 3 minus x occurring as a factor in the denominator? Do you see it exactly?
No.
No. But what should come into your mind now? Opposites. I need for you to say opposites. Opposites. What is the opposite of 3 minus x? Do you see an x minus 3 in the denominator? Yes. So you cross these out just like this. Now remember, when you divide opposites, what factor do you end up with? Negative 1. So how you're going to do this is this way. We tend to make the factor that's in the denominator a positive 1 and the factor in the numerator a negative 1. So in the past, if you notice this right here, we made these both 1s, right? Because anything divided by itself is what? 1. But when you divide factors, you don't get 1. What do you get? Negative 1. So one has to be a positive 1. The other one has to be a negative 1. All right, now let's talk how to write the answer. What is left in the numerator? Negative 1. What's the denominator? X plus 2. So there's your answer. Negative 1 divided by x plus 2. Now, you'll sometimes see the answer in the way I'm about to write it, but this is the one that we tend to use most often. But I want you to remember something. If I have negative 2 divided by 3, you need to understand that that's the same thing as saying negative 2/3, just like this, where you have that negative out in front of that fraction. So negative 2 divided by 3 is the same thing as saying negative 2/3. You could also put the negative in the denominator, say 2 divided by negative 3. But all these are different ways of writing the same expression. So when I come over here, instead of saying negative 1 divided by x plus 2, I could say negative 1 divided by x plus 2 like this, where the negative is on the outside. Because it kind of looks like this one right here. Negative 2/3, negative 1 over x plus 2. But this is the one that we tend to write. It's just, this is the way I write it all the time, negative 1 in the numerator, instead of putting it on the outside. All right, number 3. All right, number 3, you have 81 minus x squared divided by x minus 9. 81 minus x squared divided by x minus 9. You want to simplify this rational expression. What's the first step? Factor. How do you factor that numerator? Difference of 2 squares. So how are you going to factor this? Nope. That's not x plus 9 times x minus 9. How do you factor that numerator? 9 plus x times 9 minus x. 81 is listed first, not x squared. Okay, that's how you factor that. Okay, 81 is listed first, so it's 9, 9. You thought what? That's a subtraction right here. You're thinking of 9 minus x times 9 plus x. Multiplication is commutative. That's correct. So 9 plus x times 9 minus x is the same as 9 minus x times 9 plus x. Multiplication is commutative. Now, are you trying to say that's the same thing as saying x squared minus 81? The answer is no, that's not the same thing. 81 minus x squared is not x squared minus 81. 81 minus x squared does not equal x squared minus 81. In fact, those are opposites. They're not equal to each other. Okay? All right. Now, the denominator I can't do anything with, so I'm going to leave it as x minus 9. So I factor. That was the first step, was to factor. Now what? Reduce. What can I reduce? The 9 minus x and the x minus 9. Now, they're not exactly the same. They're not the same factor. But they're what in comparison to each other? Opposites. They're opposites. So that means that when I cross these out, now again, you just don't cross them out. You're really dividing these, and they're opposites. So you really say an x minus 9 into itself is what? 1. And x minus 9 into its opposite is what? Negative 1. Okay, now let me explain to you how that answer is going to be written. See that denominator is a 1 this time? So you got to remember from previous experience that if you have 8 divided by 1, you know never to leave it as 8 divided by 1 because you know that 8 divided by 1 is what? 8. Right? You know that 5x divided by 1 is, there's a better way of writing that. What's the better way of writing that? 5x. Okay? So when I come over here, I am dividing by 1. So you know you're not going to leave a 1 in the denominator. Because anything divided by 1 is that thing. But you're going to leave your answer like this. So you're going to say negative 1 times 9 plus x. That's how you're going to write it. Don't distribute. Leave it in factored form. Leave it as negative 1 times 9 plus x.
So we cannot write it as negative 9 plus x?
You can if negative 9 minus x, you can if you want to, but I would leave it in factored form. So if you want to distribute, you can. Negative 9 minus x, right?
Negative 9 plus x.
Negative 9 plus x, you're distributing. A negative 1 times 9 is a negative 9. Negative 1 times x is negative x. Okay? You distribute.
Oh, yeah.
All right, either one's fine, but I would leave it in factored form. Now also, you know that negative 1, sometimes we can leave the 1 off. So I want you to understand that that's the same thing as saying negative in parentheses 9 plus x. Just like that. Because that right here is understood to be a what? A 1. So that's negative 1. So all of these are equivalent ways of writing the answer. But notice in no case did I say divide by 1? Because you're supposed to know that this divided by 1 is this. This divided by 1 is this. This divided by 1 is this. Okay? All right, so that was number 3. Number 4. You have 6 minus x divided by x squared minus 3x minus 18. Okay, now what? You're going to factor. What can I factor? What part of this expression can I factor? The denominator. So I'm going to leave the numerator alone. I'm going to go ahead and factor the denominator. GCF is 1, so I'm going to go directly to the two binomials. And that's an easy one to factor. So you're going to say x, and it'll be 6 and 3, I think. X minus 6, x plus 3. All right, and again, before you go on, you need to quickly check this. What's the outer? 3x, what's the inner? And when I add them up, do I get a negative 3x? Yes. And what's negative 6 times a positive 3? Negative 18. So I'm good. Now the next step, once you factor, what's the next step? Reduce. Can I reduce anything? Yes, I can. I see some opposites there. I see factors that are opposites of each other. The only factor you see in the numerator is 6 minus x. You see its opposite in the denominator. What is its opposite? What is the opposite of 6 minus x? X minus 6. So when you divide these, when you reduce these, we're going to make this factor a 1, and then this one a what? Negative 1. And so what's your answer? Negative 1 divided by x plus 3. Okay? All right, so that's the idea of opposites. We're going to see this again in a little while when we go ahead and multiply rational expressions. But those are the opposites. That's the idea of opposites. Yes?
So the negative 1 always comes in the numerator.
Say it again?
The negative 1 comes always on in numerator.
So if you have 1 divided by 8, how are you going to write 1 divided by 8? Are you going to say I can remove the 1? If you have 1 divided by 8, can you just take the 1 away? No, 1 has to stay in the numerator, right? So if I have negative 1 divided by x plus 3, can I just remove the negative 1 out of there?
No.
No. So it has to be negative 1 in the numerator. If I have 8 divided by 1, then I can say that's just what? 8. Okay? All right. Okay, so, yes.
Okay, in example 3, we had 9 minus x at the top and x minus 9 at the bottom.
We had 9 plus, we had 9, which one are you talking about? You talking about these two right here?
Yes. And why we have that negative 1 at the top while we have 2 parentheses, but in this example number 4 we have 2 parentheses at the bottom, but instead we get the negative 1 at the top.
I did that here. When I reduce opposites, this is a positive 1, this is a negative 1. When I reduce opposites, this is a positive 1, this is a negative 1. It's the same thing. Except the numerator is factored as 2 binomials. Here, the denominator is factored as 2 binomials.
So that is my question, because
Just trying to figure out which one's
What makes
the
the negative
opposite.
1 at the top? Why not put the negative 1 at the bottom?
In our discussion, when we discuss this, I'm going to go back to the very beginning. 8 divided by negative 8 opposites is what?
negative.
Negative 1. Negative 3 divided by 3x is what?
Negative.
Negative 1. Okay? When I went over here and we talked about taking out the negative 1, okay? We took out a negative 1, we reduced these, you're left with negative 1, right? Okay, so we tend, I said this, we prefer, when you reduce, to make the denominator factor a positive 1 and the numerator negative 1. Okay?
Okay, so that was my question, that we have to keep it always negative 1 at the numerator.
No, that we tend to. Okay? We prefer to. Okay? Okay. It's a preference. All right? So make the denominator a positive 1 and the numerator a negative 1.